Alright, so we're going to talk today about the relative activity of metals. Now, what does this actually mean? First off, we'll talk about this little solution we have down here, which is, well, it's blue now, but it started out as silver chloride. So that one would be, that's silver chloride. So it's got silver chloride in there. And what we're looking at is silver chloride, so silver in solution with a copper coil. There's a copper coil in there. Okay, so that'll be the example we refer to start off with. Now, relative activity of metals, like what that relative actually means is that it means compared to others. So it's activity of metals compared to others. So this is a way where we can compare the activity of the copper and the silver. Okay, so it's worked out comparatively. And this is our list. Now, this is not a list that you ever need to remember. What you need to remember is how to work out the reactivity from this list when you're given it. Alright, so this is our list of reactivity. Increase in ease of oxidation. What that actually means is it is more likely to be oxidized. Okay, so it's more likely to react in this fashion here. It is more likely to be oxidized at lithium than it is at gold down the bottom. So this is our ease of activity. So if something is more active, it means it loses electrons. And we see that up here. So lithium, this is the oxidation of it losing the electrons. Okay, that happens easier than it does for zinc, and it happens easier for zinc than it does for copper. Now, if something loses electrons, we say it is oxidized, or it is an oxidation reaction. If something gains electrons, we say it is a reduction reaction. Okay, so if this is back the other way, it is reduced. So if we change the arrowhead, that becomes a reduction reaction. So more reactive loses electrons, less active retains or gains electrons. And we see down here that the silver has gained an electron and become elemental down there, and the copper has lost an electron, it's actually lost two electrons, become a cation, and entered solution. So here we have a cation, which has become elemental. Here we have an element, which has become a cation. Okay, so that's pretty straightforward. That's what we're dealing with. Now, let's have a quick look at an example. So here is zinc being oxidized. Zinc is losing electrons. We'll go through oxidation reduction another time in more detail. Here is copper being oxidized. Now, is this the way the reaction is going to go? No, it's not. If we have a look at our list over here, we can see that zinc is higher on that list. Okay, so zinc is right here, and copper is here. This means this is more active, and this one is less active. So, in that case, the one which will oxidize will be zinc here. Zinc will oxidize. So this will happen just fine. Whereas copper is less reactive, so less active, so it will reduce. It will go through reduction. Which means we can draw the zinc down here like this. It's oxidized, so it's a half ionic equation. Then we draw the reduction reaction, which is copper. So yeah, we flipped it around. So copper plus electrons goes to elemental copper. And if we put that together, we now have, we now have an oxidation reduction. I'll just write that over here. That is a redox reaction. What that means is it is a redox reaction. So we've got a redox reaction right there, and that is because we have reduction happening, so this is gaining its electrons, and we have oxidation happening where it's losing electrons. Alright, that's it. We'll spend a bit more on that in class, and we'll see you there.